Hey.
Do you know why I pulled you over?
Tell me happy St. Patrick's Day?
No. Because 10% of drivers drive drunk today, and 7 out of 9 people before you have been driving drunk.
What?
And you were swerving.
7 that's a lot of people.
Yeah.
But 7 out of 9. Wait, there's no way I'm drunk.
Oh, really?
Really? Yeah. I'm serious.
And why do you say that?
It's statistically improbable.
And?
See, if the probability of drivers being drunk is 10%, yeah, that's 7 out of 9. 7 out of 9 have been drunk. I would have 8 of a sample of 10, assuming independence and normalcy. The binomial probability of me being drunk is... I'm always prepared. What?
The probability is?
Oh yeah. 0.000000365.
That's a lot of zeros.
Tell me about
That
it.
does make logical sense. There's no way you could be drunk.
I know, right?
Right. So you're free to go.
Thank you, officer.
In the last scene, you saw a binomial PDF in action. A binomial PDF is a discrete probability distribution of successes n, each which yield a success with a probability p.
There are 4 checks to ensure that a binomial PDF will be accurate. The first check is independence.
In our case, the independence occurs from each driver's soberness or drunkenness being independent from the other drivers.
The second check is a set n, or sample size.
In our case, set n would be 10 because in our equation, 10 people came through the sober check.
The third check is a set p, or probability.
We stated that 10% of all drivers that came through would be drunk, setting our probability.
The fourth check is 2 outcomes, success or failure.
Our success and failure are either intoxicated or completely sober.
Here's what Brandon did to solve that binomial PDF and find the probability of him being drunk. First, we need our n value, or sample size. Because the cop said there had already been 9 drivers pulled over and Brandon made 10, that's 10 drivers total, so our sample size is 10. Next, we need a p-value, or probability. The cop, when he pulled over Brandon, said that 10% of drivers would be driving drunk on that day. Therefore, our probability is 0.1, or 10%. The last thing we need is an x value, or number of successes. Because there had already been 7 drunk drivers, and Brandon would have made 8, our x value is 8. Once we have all of these values, you can put them in your calculator with this formula to find the probability. First, you go to second vars. Then you scroll down to A, which is a binomial PDF. Then you enter your values for n, which was 10, p, which was 0.1, and x, which was 8. This gives you the probability that 8 of the 10 drivers were in fact drunk.
Seeing as our result probability is 3.645 times 10 to the negative second.
This means the probability of Brandon being the 8th drunk driver is 0.00003645%. Not very likely. So Brandon was right, but also very wrong.
Very, very wrong.
Remember, kids, don't drink and drive.
Yes!
It's starting to make sense to me. I can't really make you love me. No, you know I can't really make you love me. To get it done, I'm on the run. I've been on the run, my shadow weighs a ton.